example 4 says that Carla is piloting a helicopter in the wilderness at 1,200 feet above the ground, and so her helicopter is 1,200 feet above the ground, and she's searching for a downed plane, and so there's a downed plane right here. As Carla spots it, she measures its angle of depression as 53 degrees, and so Carla has to look down at an angle of 53 degrees below the horizontal in order for her to see the plane. She also spots a road whose angle of depression is 15 degrees, so somewhere off even farther out in the distance, she looks down at only an angle of 15 degrees, and out here she sees this road. And the question asks, find the distance of the downed plane to the road. And so we're looking for this distance, which is d, the distance between the road to the airplane. And the two angles that were given, they give us information about two different triangles here. The first triangle is the triangle formed from Carla straight down to the ground, out to the plane, and back up to Carla. So this is one triangle. The other triangle is from Carla down to the ground, out to the road, and back. And so these two triangles, they share this 90-degree angle. They also share this side, which is 1,200 feet. And so they gave us the angle of depression, which is 53 degrees, and the angle of depression is below a horizontal line. The ground is also horizontal, or we're assuming at least. And so when we have two parallel lines and they're cut by a third line, the adjacent angles formed have to be equal. And so if the angle of depression is 53 degrees, in other words, the angle of elevation also has to be 53 degrees. And same thing out here. If the angle of depression here is 15 degrees, the angle of elevation from here must also be 15 degrees. And so let's start by looking at the smaller triangle. We want to find distance x. If we know distance x, which is the short side of this triangle, and we know distance y, which is the long side of this bigger triangle, we can find distance d by taking y minus x. So whatever y is, if we take away x, we will be left with d. And so we should say that d will be equal to y minus x. And so for the small triangle, we know the angle of 53 degrees. We know the side opposite of that angle, which is 1,200 feet, and we're looking for the side that is adjacent. And so that's going to be the tangent function. The tangent of 53 degrees is going to be equal to the opposite side, which is 1,200 feet, divided by the adjacent side, which is x. And if we look at this larger triangle, very similar situation. We have this angle here, it's 15 degrees. We know the opposite side, which is 1,200 feet, and we're looking for the adjacent side here, which is going to be y. And so again, the tangent of 15 degrees will be equal to 1,200 feet divided by y. And so we have these two different equations here, and we want to solve them for x and y so that we can plug these equations into this one. And so if we know x and we know y, we can subtract them, and that will give us d. And so over here to solve for x, x is in the denominator. We want it to be not in the denominator, so we're going to start by multiplying both sides by x so that they cancel over here. And we get x tangent 53 is equal to 1,200 feet. And we want to solve for x, so we're going to divide both sides by tangent 53. And these cancel over here, and we get x is equal to 1,200 feet divided by the tangent of 53 degrees. Okay, and same thing over here. We want to solve for y. Y is in the denominator. We're going to start by multiplying by y on both sides so that over here they cancel, and we get y tangent 15 is equal to 1,200 feet. We want to solve for y, so we're going to divide by the tangent of 15 on both sides, and over here the tangent cancels, and we're left with y equals 1,200 feet divided by the tangent of 15. And so we're looking for d ultimately, and d is y minus x, and so d will be y, which is 1,200 feet divided by the tangent of 15 minus x, where x is 1,200 feet divided by the tangent of 53 degrees. Okay, and so now we can solve for d. D will be equal to 1,200 feet divided by the tangent of 15 degrees, close parentheses, minus 1200 feet divided by tangent 53, close parentheses. Very important to close your parentheses, especially on this first one. And then we can press equals. And so D is equal to 3,574.2 feet. And so the distance between the plane to the road is 3,574 feet.